Hello everyone, today Group 2 will be presenting Convolution Assignment SEEE 2073 Signals and System. Our group member got Arun Kumar, Chong Ji-sen, Ling Sao-an, Wang Ken-yang, and me, Wong Wei-heng. Introduction of the video. The purpose of this assignment is to calculate the convolution operation to describe the response of a linear time invariant system (LTI) and use MATLAB to plot the results of this operation. In this assignment, students will analytically evaluate and verify results using MATLAB. What is convolution? Convolution is a mathematical operation on two functions that produces a third function that expresses how the shape of one is modified by each other. Now I will pass to my friend Arukuma and he will show you how to calculate convolution operation step by step.
Hello, my name is Arun Kumar. So, for today, I will be presenting the manual calculation of task 1 for my group. So, over here, we have obtained the function from the graph given from the question. So, for the second, we are adding up both of the functions. As you can see here, we're just adding up the amplitudes, which will result in the zt function shown over here. Okay, that's for the second part, and we are moving on to the third part, which is over here. We're doing the convolution. Okay, this is the convolution formula, as you know. So for the first function, we are replacing t with tau, so there's no changes here. And for the second function, we're replacing the thing in the bracket with t minus tau, which will result in inverse of tau first. We do the inverse. Okay, there's no changes here. It looks same from both directions, so in both directions. And then we'll shift to the left by t. Since the length is 2 here, when we shift to the left by t, it's t and then here t minus 2. Since it's 2 here, it's t minus 2. Okay, that's that. Okay, so for the first part, when t is less than 0, okay, there's no overlapping here, so it will result in 0. Moving on to the next slide. When t is from 0 to 1, as you can see, there's overlap here at this point. Only here, so we'll take 2 tau here. So overlap is between 0 to t, so 0 to t, we'll integrate that, and then we get the function. This is the function we obtain. And for t is 1 to 2, we're doing the same. So for this part, the overlap is here, which is 0 to 1, 0 to 1, 2 tau, and then integration of 1 to t, and then the other function over here, which is here. Okay, so integrate both of that, eventually we'll obtain this. So moving on to the third part, which is t in between 2 and 3. As you can see, it's over here. And doing the same from t minus 2 to 1, 2 tau integration, and from 1 to 2 with this function we integrate, and we obtain this function at last. And also from 3 to 4, there's overlap here. Since there's overlap here, it's from t minus 2 to 2 only with this function, so we're doing it right here, the integration of it. Eventually we're obtaining this function, and since there's no overlap when t is more than 4, so we don't do that. So we obtain this at the last. Using this, we're going to draw a graph, okay, which will result in from 0 to 1 it's t squared, and then from 1 to 3 it's this function over here, and then from 3 to 4 it's this function over here. When t is more than 4 it's 0, when t is less than 0 it's 0. That's how we get yt. Okay, that's that for the manual calculation of task 1. Thank you.
Good afternoon, my name is Lim Shao An and I'll be explaining about the MATLAB code used to prove our manual calculations in task 1. So the first line is the code to create time samples, which is from -1 to 2 seconds, since that both signals are within this range. And for line 3 until line 7, it's data for the signals x1t and x2t. So with this, we can generate the signals as stated in the first question. So on line 9, we have yt equals to the convolution of x1t and x2t. We have to divide it by 10,000 because in line 1 we used a resolution of 0.1 milliseconds. So moving on, we have the time samples for the convolution results, which is from -1 to 5 seconds. From line 12 to line 20, it's actually to calculate the result of yt for each time sample, based on the equation that we got from our manual calculations. And now we start to plot the graph. So the first subplot is x1t and x2t, followed by the legend, axis and title of the graph. And in subplot 2, we plot x1t, x2t and x1t plus x2t, which is zt. And by comparing it with the graph that we drew, it can be said that our manual calculations are correct. So the last subplot is to plot two signals. One is yt that we obtained from MATLAB calculations, and another one is the yt that we obtained from the manual calculations. So if you look at line 42 and 43, the MATLAB calculated yt will be thicker than the manual calculated yt when they are plotted onto the graph. So from the graph that we plotted, we can say that both results are the same. The black line, which is the MATLAB calculated yt, is the same as the orange line, which is our manual calculated yt. And from this, it can be said that our manual calculations are proven to be correct. So the last line of code is just to clear out all the variables, which isn't really important for this assignment. So that's all. Thank you.
For the second question, we need to sum up both the signals. The additions of GT and HT will generate the output as shown as here, ZT. For the third question, before carrying out any calculations, we have to modify the signals first, from GT to G tau, and then from HT to H negative tau, which is the time inversion, and then time shifted with T. So this is the output. So in the first case, both signals are not intersected, which means T is lesser than -1. Alright, the output is 0. And then next is when the unit step function is partially inside the ramp functions, which is when T is in between 0 and -1, and the output will be T squared plus 2, T plus 1, right? Moving on, the unit step function is fully inside the ramp function, okay, which is T in between of 0 and 1, and the output yields 2T plus 1. And the next case is when both of the unit step function is partially inside the ramp function, and that is when t is lesser than 2 and greater than 1, and the output is negative half t squared minus t plus 9 over 2. Then we have one of the unit step function is inside the ramp function while another one is out, which is when t is in between of 3 and 2. So the output will be 3 minus t minus 3 over 2. And then lastly, we have one of the unit step function is still partially inside the ramp function, which is when t is greater than 3 while lesser than 4, and the output is half t squared plus 4t. Finally, we have the both signals are not intersected again, which is when t is greater than 4 and the output is 0. Collecting out of the equations we have calculated within the specified time domain, a graph can be plotted, which is yt.
Hi, I'm Hua. So I'm going to explain the MATLAB code for the class 2. So first we create a SSC data for GT and HT, and the sample period is 0.1 millisecond. So next one we create the YAC data for the signal GT and HT. We calculate the convolution for GT and HT, and then each divide by 10,000 because of the 0.1 millisecond sampling rate. Next one, we create data for YT. The sample period is 0.1 millisecond. We also create SSC data from -1 to 0, from 0 to 1, from 1 to 2, and then from 2 to 3, from 3 to 4. That one we are used for calculation. So we also calculate the YS data for manual calculation result. We create a first subplot. We plot the data for GT and HT. So next one, we assign legend, acid and limit. We assign legend, acid limit and title for the second subplot. Streamline. So we create the second subplot. We plot the data for GT, HT and JT, and then we assign the legend, acid limit and title for the second subplot. Okay, so we create the third subplot. We plot the data for MATLAB calculate YT and manual calculator YT, and then we set the subplot line with for clearer graph, and then we assign legend title for the third subplot, and we create the all unused data. So at the right side you can see there is the output, means the result from the MATLAB code. So that is all. Thank you.
In the end, we were able to achieve identical results through MATLAB code and manual computation for both task 1 and task 2. Through this, we can verify that our group meet the assignment objective by doing so. That's all from us. Thank you for watching.